Welcome to lesson 10 of SQL Fundamentals. We have reached an important transition point. Up to this point, we have built a strong foundation with joins, filtering, sorting, aggregation, having, case, when, subqueries, views, and CTEs. Window functions deserve more than a quick demonstration. In fact, we have a separate master SQL window functions 0 to hero series dedicated to them. So this lesson is intentionally different. There is no SSMS demo. My goal is to give you the big picture, what problem window functions solve, why analysts use them, and why you should learn next. By the end of these few slides, you should be able to recognize when window function may be the right tool, and you will know exactly where to continue for deeper hands-on journey. Let us start with the problem, not the syntax. Group by is one of the most useful tools we learned in SQL Fundamentals. If leadership asks for total paid amount by specialty, group by is exactly what we need. But group by changes the grain of the result. Thousands of claim rows may become 20 specialty summary rows. Now imagine leadership asks a different question. Show me every provider, but also show how that provider compares with other providers in the same specialty. We need the detail row to remain. At the same time, we need a calculation across related set of rows. That's why window functions become extremely powerful. The important idea is not that window functions is replacing group by. They solve a different analytical problem. Group by is still the right tool when business needs summarized result. Window functions become valuable when we need analytical context without collapsing the underlying rows. This visual is the concept I want you to remember. On the left, group by takes multiple provider rows and produces a specialty level summary. That is not a weakness, that is exactly what aggregation is designed to do. On the right, a window function can calculate something such as the specialty total while the individual provider rows remain in the result. That means provider A can still be provider A, provider B can still provider B, and each row can carry additional analytical context. This is why the word window is useful. SQL is performing a calculation over a window, a set of rows related to the current row, without necessarily reducing those rows into one output row. This ability becomes especially valuable for ranking, running totals, comparisons, trends, and analytics where the relationship between rows matter. Here is the general shape of window function. Do not worry about memorizing the syntax from this slide. We are only building the mental model. First, we have a function. In this example, rank asks SQL to assign ranking. Then we have over. Over tells SQL that this calculation should operate across a window of rows. Partition by can divide the result into logical groups. In healthcare analytics, that might mean ranking providers separately within each specialty rather than ranking every provider against every other provider. Order by inside over defines the analytical order. If we order by total paid amount descending, the highest paid amount is considered first for the ranking. There are additional details and important nonsenses, including how order by behaves inside over and how window frames work. Those are exactly the topics we explore step by step in dedicated window function 0 to hero series. Mental anchor for the learner. Partition by answers. Which bucket does the row belong to? Order by answers. What is the sequence inside the bucket? It is similar to grouping conceptually, but partition by does not collapse the detailed rows. So partition by tells SQL the buckets, order by tells SQL the sequence inside the buckets. Window functions are not one function, they are entire analytical toolkit. Ranking functions such as row number, rank, and dense rank help us sequence and rank records. Aggregate functions such as sum and average becomes even more powerful when used with over. We can calculate running totals, moving averages, group totals, and comparisons while retaining details. Lag and lead allow us to look at previous or next records. think about comparing member's current claim with the previous claim or this month amount with the last month amount. First value and last value can help us retrieve values from the beginning or end of an analytical window. Entile can divide population into buckets. For example, provider cost quartiles. Percent rank and cumulative distance help describe relative position within the population. We are intentionally not teaching all of these in the slide. The purpose is to show you the horizon and why window functions deserve their own learning series. Now connect the concept to the kind of work we are doing throughout this channel. Suppose we want the highest cost providers with each specialty. Ranking functions are natural fit. Suppose we want cumulative claim spending over time. A running sum can help. Suppose we want to compare a member's current claim with the previous claim. Lag becomes extremely useful. Suppose we want to sequence visits or claims within each member. Row number can help us create that order. Suppose we want every provider row to remain visible while also comparing that provider with a specialty benchmark. That is another classic window function use case. And if leadership want to segment providers into quartiles or other groups, Entire gives us another analytical option. These are not artificial syntax exercises, they are common shapes of real analytical questions. That's why window functions are such an important next step after SQL fundamentals. If this introduction makes sense, you are ready for the dedicated Master SQL Window Functions 0 to Hero series. Video 1 starts with the most important question: why do window functions exist? Video 2 focuses on over because over is the foundation that makes window calculation possible. Video 3 goes deeper into partition by and shows how we perform calculations within logical groups. From there, the series continues into order by inside over, ranking functions, entile, lag, and lead, first value and last value, aggregate window functions, running totals, moving averages, percentile functions, window frames, performance pitfalls, and real-world combination. So instead of compressing all of that into one SQL fundamental lesson, I wanted to learn it properly in a series designed specially for that journey. And with that, we have completed the concept journey for SQL fundamentals. Think of learning path in 3 stages. First, SQL fundamentals gives you core toolkit. Second, the window functions 0 to Hero series takes one of the most important analytical areas of SQL and develops it in much greater depth. Third, our healthcare claims analytics capstone brings the concept together around realistic business problem. You do not need to master every window function before moving into the capstone. At this point, I want you to understand what problem window functions solve and why analysts use them. Now we are going to stop learning SQL concept one at a time. We are going to take our healthcare claims DB, work from a stakeholder question, investigate the data, identify cost drivers, and use the SQL skills from this fundamental series together. That is the transition from learning SQL syntax to thinking like an analyst. Thank you for completing SQL Fundamentals series with me. I will see you in the Healthcare Claims Analytics project. And when you are ready to go deeper, continue the Master SQL Window Functions 0 to Hero series. Before we close, remember this: you are not expected to master advanced window function syntax from lesson 10. This lesson gives you the conceptual keys, keep the detailed rows, analyze across related rows, and understand the roles of over, partition by, and order by. That is enough to enter the 0 to Hero series without being intimidated.